Okay, so hi everyone. My name is Krystal, and I'm a senior front-end developer at Shopify. I've been working with front-end development and design for about 10 years now. And during this time, I've had the opportunity to work in a wide range of projects, from mobile apps and games to, of course, apps and even virtual reality. So today we are going to talk about how we can mix color theory with JavaScript in order to allow us to generate accessible color schemes. The examples that I'm going to present here today will be uploaded to my GitHub account. And if you have any questions or curiosities, just ping me on Twitter or come talk to me afterwards, because I don't bite. Before we start, I would like to remind everybody that HTML is accessible by default. And what usually happens is that we introduce custom styles or functionalities that ruin the accessibility. And I also know that it can be hard for us to convince our bosses or clients that it is worth to spend the time and effort into making our apps accessible. So I'd just like to run through some numbers. Around the world, we have 785 million people that live with some sort of disability. That's 26% of the population in the US, or 1 in 4 adults. If we talk specifically about people living with color blindness, we have 300 million people. That's almost as much as the entire population of the United States, or 1 in 12 men in the world, or 1 in 200 women in the world. That's a lot of people that can be affected by the colors you choose to put in your application. And I'm not even talking about people that have other sorts of low vision or low contrast issues or cognitive disorders that can also be affected by the color choice. Plus, I think nobody wants to be like Beyonce and get sued because of a website that is not accessible. So accessibility actually covers a lot more than just colors. We should also keep in mind things like keyboard navigation and semantic HTML. But as the main focus of today's talk is color, we should probably start with a little bit of color theory. So what is color theory? Basically, it's a body of practical guidance in terms of mixing colors for arts and design. It started with Sir Isaac Newton when he created this diagram that you can see on the left, where we basically organize the colors around the wheel in order to understand the relationship between one color and the other and how to mix and match. After he created the first diagram, a lot of other people started creating their own versions of the color wheel. So, and actually, everything that we do nowadays in terms of creating colors with technology comes from these early studies of color theory. So we can start with a little example of how to actually code a color wheel, like the one that Bootsec created with 12 color slots. So to do that, we can start with a little markup. Basically, we have, actually before, how many of you are familiar with Vue.js? Raise your hand. OK, most of you. So for those of you who are not familiar with Vue.js, it's basically a JavaScript framework that allows us to manipulate the DOM in a really easy way. So that's why the examples that I'm going to show here today, I'm using Vue.js. But of course, the concepts that I'm going to explain, you can apply with the technology of your choice. So basically, I have 12 list items. I'm just using the v4 here to loop through and render the 12 color slots that we are going to have in our color wheel. And then afterwards, in my Sass file, I'm using a for loop again so that I can adjust the color and the position of each list item. This means that inside of the for loop, I have a new angle that is basically 30 times the index of that specific item in the list. And this 30 is not a magic number. It's just because we have 360 degrees in the full wheel. And then we divide it by the 12 color slots that we have. So with this new angle, I can rotate each color slot until it gets to the full circle. Then for the new color, I'm using this adjust hue method that comes built in with Sass. And I'm using the same new angle to rotate the main color until it reaches the new position. This on that part, because I'm just creating the variables, and to actually apply them to the CSS, I use a transform with a rotate, and I rotate each list item to its new position based on the new angle. And I also apply the new color to the border color of that list item. And notice that I'm not using the background color for the list item. I'm using the border color because I want each list item to have a triangular shape and not a square shape, so that I can have these pizza slice and rotate them around until I have a full wheel. One thing that I think is really useful for us is to actually be able to see the degrees around the wheel. So we can use a similar technique, but I want smaller steps between one list item and the other. So I'm creating 24 list items, and I'm printing out the new angle as content of a pseudo element after. This is how we managed to get the numbers around the wheel. Now that we have a simple color wheel with the default colors, we can actually refactor that and go one step further to actually analyze the relationship between lighten and darken colors to help us understand shades and not only hues. So we can rename our colors class to default colors and also introduce 2 extra rings for lighten and darken colors. Once we have that in our markup, we can change our Sass file to actually use the lighten and darken Sass functions to alter the colors of each slot from the outer and inner rings that we just created. So this is the final result for that. And you can see that everything is calculated based on the main color. So once we change the main color variable and the CSS gets a chance to recompile, all the other colors are automatically updated. Not only that, but I can also adjust how dark and how light I want the extra rings to be. Having a color wheel like that is interesting because it helps us understand how to create color harmonies. So, for example, you could have something like analogous colors, where you choose one color and then afterwards you get all the adjacent colors to form your color harmony. Or you could have something like complementary colors, where you basically select one color and then you select the color that is opposite from that color on the color wheel. Or you rotate your main color to 180 degrees. You could also have split complementary colors, where you basically do the same thing. You select one color and then you rotate that color until you form that triangular shape on top of the wheel. And the same thing goes for square and triadic colors, that, as the name says, you have a square or a triangle shape on top of the color wheel. This is all super nice, but the problem is that up to this moment, only us as developers were able to manipulate the colors, right? Because the browser doesn't understand Sass. The browser can only understand CSS. So to actually allow the final user to select the color scheme of a website, we have to introduce JavaScript. So we can, for example, create a simple interface like that, where we have an input with a type color to allow the user to select the main color, and also we can allow the user to select what color harmony he wants to use. Dealing with colors in JavaScript is a bit tricky, so I'm using the npm package color. And on this section here, I have basically an H2 with the selected color scheme based on whatever the button the user clicked. And I'm also using a v-for again that's basically looping from 1 to 4 so that I can have 4 slots in my color scheme. Of course, depending on the color harmony that the user selected, I'm not going to have 4 colors, right? Because, for example, if he selects complementary colors, I only have 2. The color that is the main one and also the one that is opposite to that one in the color wheel. So in those situations, I just repeat them in order to fill the 4 color slots of my color scheme. Then again, here is my input with the type color. And I also have a vModel that is basically a way for me to easily access the color that the user selected. And I have an update color that is called every time that this value changes. This update color method is basically going to update all the variables that I have on my CSS. And this time, I'm using CSS variables, not Sass variables anymore, because this is something that the browser can understand. So basically, I just have to refer to this variables that have the 2 dashes in the beginning, anywhere in my styles, so that everything gets automatically updated as soon as the user selects something else. And then I have a collection of buttons that I'm looping through all the available color schemes inside of a color scheme object. Each color scheme is going to have its name, for example, complementary, and also angles. Since we have 4 slots in each color scheme, I have 3 different angles that I'm going to rotate the primary colors. So 4 colors, 1 primary color, plus the colors that get generated by rotating the primary color to these 3 angles. And basically, when I click on a button, I'm just going to update the selected color scheme to whatever I clicked. Another interesting thing is that I can use computed properties to observe the changes of the primary color in order to automatically update the secondary, tertiary, and quaternary colors. So basically, I'm just observing here the primary color that was selected by the user and the selected color scheme, and rotating that primary color to those angles that are inside of the color scheme. So now we know how to create color harmonies based on one initial input from the user. But one of the most important things when you're talking about accessibility is actually making sure that the colors have enough contrast when we are putting text on top of a certain background. If you try to run an audit on the Twitter website, you will notice that all of the color themes that Twitter allows us to choose are not accessible. So you can test that by just running an accessibility test inside of the Audits tab of the Chrome Developer Tools. Or you can use something like X, which is a different Chrome extension that is also going to allow us to test for accessibility. And you can see here that 53 elements don't have enough contrast, basically because all of the text that's written in blue, all the hashtags, all the links, all the buttons, they don't have enough contrast on top of the white background. So that means that for many users, they are not going to be able to even see that text. Another really interesting tool that I like is the No Coffee Vision Simulator, because it allows us to actually see the website as somebody with lots of different types of vision disorders would see. So you can test for different types of color blindness, cataracts, etc. Okay, so we can combine those 2 different informations that we have now to actually start generating accessible color schemes. As an example, I created this fake snowboard shop that has a similar interface as the one that I showed before. Basically, the user can select a main color, and then we have a dark and light mode. And you can also select a color scheme based on those color harmonies that I showed before. And I have a little preview there that show how the 4 colors are going to interact together. Once again, I'm using the color package from NPM, and I'm also defining a constant of minimum contrast to 4.5. That's also not a magic number. It comes straight out of the WCAG documentation. For those of you who are not familiar with WCAG, it's basically the organization that is responsible for defining the accessibility standards in the web. So here I have a store app component that is basically the interface of that snowboard shop, and it receives a primary color as props. This is interesting because it allows me to directly access the string of the color that the user selected and use it to change the color of all of the SVGs that I have, for example, icons and the logo and this kind of thing. And then I have the input, again, with the type color, and the update colors method that is going to update the variables in my CSS. The only difference here is that instead of just saving the color that the user selected to the CSS, I'm actually passing this color to this generate text and background method. And what this method does is that it checks if the color that the user selected is light, and then it decides to show the text in either black or white. In some situations, the color that the user selected, even with text that is black or white, is not going to have enough contrast. So to solve that, we can actually grab the initial input from the user and darken or lighten it a bit until we have enough contrast between the background and the text. And then I'm returning the colors again, 1 color for the text and 1 color for the background. And once again, I'm using the update color variable to override the values in my CSS. But this time, I'm saving not only a primary color, but a primary text color and a primary background color, because I know that they can be used together with enough contrast. Turning text to black and white is a really simple way of solving accessibility issues, but you can do stuff that is more interesting, right? So for example, you can have the color that the user selected, check it to see if it's light or dark, and instead of just using text that is black or white, you can actually grab that color and darken or lighten it a bit, so that you have this kind of effect of having like a darker shade of blue on top of a lighter shade of blue. Yeah, and also we have modes that are dark and light. And one way to achieve that is basically watch for changes in the mode variable. And because we know that those colors are always going to be used together, it's just a matter of choosing a dark or light mode. I can just hard code the colors there because it's not always ever going to change. Another example of things that we can do for the links, for the link colors, I'm actually getting the quaternary color generated in the color scheme, which is basically the last one, which is going to be always the most different one from the color that the user selected. And then I'm doing a similar thing, but this time I know that all the links of this website are going to be shown on top of a white background, so I can just check for the contrast there, and then darken the color until it has enough contrast. And here on the color scheme, it's exactly as we saw before, a bunch of color schemes that are basically objects that have names and angles that we can rotate the main color to. And we can create the radio buttons with the selections based on those objects. And for the computed properties, for the secondary, tertiary, and quaternary colors, I'm using the same generate text and background method that's basically going to look at the color that the user selected and generate colors that can be used for text and background and have enough contrast between them. Since we have all of those variables saved in the CSS already, we can also use this kind of thing to achieve different kind of effects. For example, in this case, for the banner of the website, I can apply an overlay to the image that basically has the color updated as well as the other CSS variables that we have. And also the text background there is also being updated by those same variables. So in order to achieve that, we basically have a banner class with the background image. And then I have a border bottom that has a secondary color attached to it, and also an overlay, which is basically another transparent div that I put on top of that background image. And then I create a linear gradient, which is basically a CSS gradient that goes from the tertiary background color to the quaternary background color. So this way, we can actually start playing around with some interesting filters for images that also match the color scheme that we created before, and we make sure that the colors have enough contrast between the background and the text. I'm also going to upload the slides later on, so here are some really interesting references that you can check if you're interested into this. And that's all that I have for today. Thank you.